Hello, my name is Chris Gromek and I'm a Senior Product Manager of Generative Design in the Office of the CTO here at PTC. And I'm pleased to talk to you today about how we are creating ways for designers to be more productive and more creative than ever before in their jobs. The way we're doing that is through generative design. Generative design is a way to take designs from a creative spark into physical reality faster than ever. See, a designer's job is to take an idea and define every feature, facet, fillet, part, subassembly, assembly, or system needed to make that idea a fully functional reality. And a designer is good at his or her job if they have two things. One, good ideas. And two, the ability to reflect those ideas perfectly in those individual parts and components that are going to be made. Now, we are never going to replace human creativity. It'd be a fool's errand to even try. But that process of defining all of these individual steps, that can take days, weeks, months, or years. And that's where we can lend a hand. So let's take a look at what a designer actually does produce, all right? This is a part 3D printed for model representation from Jacobs Engineering. It's a CO2 sensor bracket that goes on a portable life support system that astronauts will wear as they travel to the moon or beyond. And its job is absolutely necessary because it monitors the amount of carbon dioxide that astronaut is going to breathe. Now, this bracket is really intended to do one thing, all right? It's got to hold some sensors and it can't break during the rigors of space, all right? It's drawn this way because the design engineer who did it had years of experience that told him or her that this was the best solution. This design, when actually made in the correct material, probably titanium, is more than enough to do its job. But that more than enough is a bit of a problem because every ounce that goes into space that isn't needed is an ounce too much. It costs over $10,000 to put a kilo into space, all right? And Jacobs Engineering is fighting for contracts with very thin margins. So we want to give them every tool that we can for them to hit exactly what they need. With our software, we can say, you know what, possibly there's a better solution out there. This is our representation of everything that they could have, all right? This is a design space. This is like the sandbox in which that designer is allowed to play and create his or her geometry, all right? Now, with our software, we can take this abstract volume, impose our functional requirements, the ways in which it has to hold on to those sensors and not break, and turn it into completely different shapes like this, all right? The way the software does that is by performing three functions. First, it makes shapes. Second, it tests those shapes. And third, it decides which of those shapes was best. Said another way, it makes use of our proprietary volumetric geometry kernel, our multi-physics simulation platform, and our artificially intelligent optimization scheme. Now it goes through this cycle many, many, many times, recreating in a sense the many, many iterations that the designer would have to do manually. And it works autonomously without the designer ever having to touch it. Much like Mother Nature, it's unbridled in its pursuit of perfection. And because of that, you're able to get topology, shapes, that look a little bit different than what you would normally get. Here we've got another generative design. Both of these are perfect in their own respect, but somehow they're still different. Because this one can be manufactured in traditional means, and this one can be manufactured additively, all right? Which means that there's actually differences in the requirements of these two designs. And because of that, you get different performance and different shapes, all right? This is the one that's going to be going to space. Jacobs Engineering knows that they need to make it as light and strong as possible, and they're only going to make a few of them. As I said before, Jacobs is looking to cut every ounce out. We know that they don't have to print too many of these in volume because there's only going to be a few astronauts that are going up there. But what makes this so unique is that the designer didn't have to think any further than what they wanted out of this part. To do this by hand would take ages. So every ounce counts. Every ounce allows for more science in space. And every ounce that Jacobs shaves means that they're more likely to get the next contract. And in terms of delivering value to our customers, that's what we hope that they'll be able to do with our tools. Very proud of the work that Jacobs Engineering has been able to do with generative design. Very proud of some of the other work that we've been able to do. But they've been working with pre-release software, kind of behind the scenes with some of our core developers. But I'm personally very excited for the initial release of this technology in Creo 7. And at that point, I can't wait to see all the different companies who are going to tear this loose on their designs, and hopefully we really will see a new way that every designer performs his or her job. Thank you.